Hey there, scholars. This is Mrs. Bowers. Today I want to give a little refresher on the skill that we worked on earlier today with adding and subtracting mixed numbers. We've already done some work with adding and subtracting fractions. Now all we're doing is we're just adding in some whole numbers in there as well. So we're doing the exact same process as we did last week. So the standard is 5NF 8.1, which is just basically saying that we are adding and subtracting mixed numbers by using a variation of strategies to get us there. So just a refresher on the steps that we take. This is my original problem, 7 2/5 plus 4 3/4. I immediately notice I can't add these fractions yet. I can't add these mixed fractions yet because the denominators are not the same. So earlier during my small math groups, I had a few of my scholars help me get started with this process. So they told me that they needed to skip count by 4 and 5 to find the LCM, which was 20. So then we rewrote the fractions with the LCM as the new denominator as 20. My scholars asked themselves, how did I get from 5 to 20? I multiplied by 4. So if 5 times 4 is 20, then 2 times 4 is 8. And we just brought the whole number over with us. 7 stays the same. Same process here. How did I get from 4 to 20? I multiplied by 5. So if 4 times 5 is 20, 3 times 5 is 15. Now I can add because my denominators are the same. So 8 plus 15 is 23. My denominator is still 20. And then I can add my whole numbers. 7 plus 4 is 11. Now this fraction is called an improper fraction because the numerator is larger than the denominator. We learned about this in third grade about improper fractions. I told my scholars who were experiencing some frustration and difficulty, I said, you know what, if this is the step that you can get to today, that's A-okay with me. If you want to challenge yourself and push yourself to the next step, we can take this improper fraction and turn it into a mixed number and then add it to the whole number we already have. So when I break apart 23 20ths, what that is saying is I have 20 20ths plus 3 20ths because 20 plus 3 is 23. Now, because we know that when a numerator and denominator are the same number, that's equivalent to 1 whole. So this is like saying 1 whole plus 3 20ths. Now we can add that with the existing whole number. So we can do 11 plus 1 plus 3 20ths. So our final answer is 12 and 3 20ths. Okay. Sorry, that's meant to be a 0, sorry. All right, so I want to try another example with you, but this time we're going to use subtraction. I'm just going to slide this up. The reason why I'm kind of going a little bit quicker than I normally do is because these first few steps, my scholars are really familiar with by now already. Okay, so next I want to do 3 1/4 minus 1 7/8. This problem we worked on during morning work this morning. Okay, so first things first, I need to recognize that my denominators are not the same. I have a 4 and I have an 8. So I need to skip count to find my LCM. 4, 8, 12, 16. We can just do 4 or 5 there. And then skip count by 8s. 8, 16. Oh, you know what? I'm going to stop because I already see a common multiple, and that is 8. So when I rewrite these fractions, I'm going to rewrite these fractions with my LCM as the denominator. But what's really nice is that my original fraction, 7/8, already has 8 as the denominator. So all I need to do is carry down my original fraction. If you wanted to go through this process, you could. We know that 8 times 1 is 8. Whatever you multiply with the denominator, you multiply with the numerator. So if 8 times 1 is 8, 7 times 1 is 7. That's why that's going to stay the same. We look at our next fraction. We ask ourselves, how did we get from 4 to 8 as a denominator? We multiplied by 2. Whatever you multiply with the denominator, you multiply with the numerator. So if 4 times 2 is 8, then 1 times 2 is 2. And then we just carry down our whole number. Now we can subtract because our denominators are the same. But here's my issue. I can't do 2/8 minus 7/8. So what could I do? Ooh, I know. I'm going to do the opposite of what we did up here when we took our improper fraction and turned it to a mixed number. I'm going to do something similar but a little different. So watch how I solve this. So I'm going to take one of my whole numbers. I see that 8/8 is the same thing as 1 whole. So if I take 1 whole away from 3, this will now become 2 and 2/8. No. 2 and 2/8. Oh, but I'm sorry. We need to take into consideration the 8/8 that we borrowed, I guess you could say. So we could say 8/8 plus 2/8, I apologize, is 10/8. I'm sitting here thinking, wait, what am I doing wrong? Hold on. Sorry. It's been a very long day. So when I take 1 whole away from 3, that's like taking away 8/8 to give to my fraction. So 2/8 plus 8/8 is 10/8 minus 1 and 7/8. Now I can subtract. 10/8 minus 7/8 is 3/8. Now I can subtract my whole numbers. 2 minus 1 is 1. And that's 1 and 3/8. Let's do one more. Let's do an addition, and that'll wrap up review for today. Okay. Alrighty, let's try 1 1/2 plus 4 1/4. I can tell just by looking at it, I cannot begin adding because my denominators are not the same. I'm going to skip count 2, 4, 6, 8. Skip count by 4 is 4. I'm stopping right there because I see my LCM is 4. What's so lovely is that this denominator is already 4, so that fraction is going to stay the same. We don't have to do any work to it because the denominator is already 4. We do, however, need to do some work to my other fraction. How did I get from 2 to 4? I multiplied by 2. So if 2 times 2 is 4, 1 times 2 is 2. Bring down my whole number. Now I can add these two mixed numbers together because I know that 2/4 plus 1/4 is 3/4. 1 plus 4 is 5. Here's my final answer. Scholars, do the best you can with today's work. We will be spending some more time reviewing, adding, and subtracting mixed numbers. And Friday, we are going to have our fractions test to wrap up our adding and subtracting fractions unit. All right, so good luck, and I'll see you guys all tomorrow.